Hi guys, today we're going to be talking a little bit more about latitude, but in relation to a star called Polaris. And you may have heard of Polaris before, maybe referred to it as the North Star. And we're going to be talking about why Polaris is called the North Star and why it's important for latitude. So let's just start with some basics of astronomy, which we're going to be getting into later in the year. First, we know that the Earth rotates, meaning it spins on its axis. And the way that we know this is because the sun rises in the east and it sets in the west. And therefore, the Earth is rotating from east to west. And we might describe this as counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. But we'll be getting into a little bit about that stuff later on when we get to some meteorology and some astronomy later in the school year. Now, the other thing that we do notice is that stars move around Polaris. And I'll show you what I mean by that with some pictures in a second. But we know that the Earth is spinning. Okay? Now, the big key thing is that the Earth spins or rotates 360 degrees in one day. And therefore, if you were to observe the stars and were able to see them even during the daytime, they would move around in a big circle 360 degrees around Polaris, and they would do that in one day. Okay. Now, the reason that they rotate around Polaris is because Polaris, the North Star, is directly above the North Pole, as you can kind of see on this diagram here. So if you were to extend a line straight up very, very far out into outer space, you would end up going up here to a star called Polaris. And it's not exactly at the North Pole, but it's pretty darn close. Okay, so it's on what we call the North Celestial Pole. This is a celestial sphere. It's a projection of all the stars around us, Earth there in the center rotating. Okay, so the sun looks like it's going around us, and all the stars look like they're going around Polaris as well. Okay, so what does that look like? Well, you may have seen one of these before, and this is a time-lapse image of the night sky, and it's done by taking a fancy camera and opening up the shutter and leaving it open for a period of time so that it gathers light for a period of time. And as you can see, we get star trails, and these trails are just a projection of their movement in the nighttime. Now, if you look closely, you'll see that there is one star that is not moving. It does not have a trail, and that star is Polaris. It's right here. And you can kind of mimic this by standing up and just looking at a point directly above you and then spinning around. And everything will look like it's spinning except for that one point that's directly above your head. That's exactly what's happening with Polaris. Polaris is directly above the North Pole, and everything else looks like it's spinning around us. Okay? So that's essentially what's going on in the night sky every day and every night. Okay? So think about this. This image, I should show you this one before I move on. This image shows, again, the same idea. We have star trails. We just have a longer time lapse in this case because we have longer star trails. Okay, and we'll talk more about that as we go on in the school year. But there it is. Polaris is right there in the middle. So important to note that Polaris is the North Star, and all the stars are going around Polaris. Now, why is that? It's not because the stars are moving. It's because the Earth is rotating. And that's super important. So remember that. Okay? Now, you might be asking, well, how do I find Polaris? How do I know where the North Star is located? And what you do is you use the Big Dipper as your guide. I'm guessing that all of you could probably find the Big Dipper in the night sky. It's a pretty noticeable and recognizable constellation. It's part of a bigger constellation called Ursa Major, the Big Bear. And you can see here there is a tail to it, or it looks like a frying pan or a pan, and you can see it's got a handle. And here at the end, there are two stars, Merak and Dubhe, which are pointer stars. We use them to line up, and then we extended a line away from here, up in the night sky. There's nothing in the middle here, really. And then there's a bright star, that's Polaris. That's actually the tail of the Little Dipper, okay, which is right here. So Polaris can be found by using these pointer stars in the Big Dipper. So let's practice with that. So here's a picture of the night sky. Maybe if you were out away from any city lights, you might see something like this in the night sky. And so what we have to do is let's try to find Polaris in this image. And maybe you already found it, but I'll help you. Okay, first find the Big Dipper. Here's the tail of the Big Dipper. Okay, and then we use the last two stars, Merak and Dabha, and we're going to use them to project a line this direction. And if we go that direction, obviously you guys are probably ahead of me. There it is. There's Polaris, and you can see it pretty brightly in the night sky. Okay, so that's how you do it. Let's try it one more time. Let me erase my screen here. I'm going to erase everything here. And we'll do this one more time. I'll show you another image of the night sky and see if you guys can find Polaris one more time. So here we go. Here's another picture. Okay, so can you find Polaris? Hopefully you spotted it pretty quickly. First, find the Big Dipper. It's over here. And then use the pointer stars. And if you project a line, you'll end up being right there. There's Polaris. Okay, so that's how you do that. You use the Big Dipper as a guide. Now, the cool thing, fun fact for you, this is a state flag. And if you know which state it is, I'm impressed. This is the state flag of Alaska. Okay, the state flag of Alaska has the Big Dipper and Polaris. Okay, now, very, very important. This is probably something you should write down. Polaris can only be seen in the northern hemisphere. It's called the North Star for a reason. It can only be seen in the north. Okay, and there's a reason behind that I'm going to sketch out in a second. The other thing that's really important is that the altitude of Polaris above the horizon tells the latitude where you are standing. In other words, the altitude is the latitude. Helps you find where you are. So I'm going to describe both of these things in a picture. So let's go to my whiteboard and kind of talk about that a little bit. So first off, let's deal with the idea that you can only see it in the northern hemisphere. So if you draw Earth, okay, here's the equator. So this is the northern hemisphere. I'm going to write NH on here. Polaris is, again, extended out from here directly above the North Pole. So it's out here somewhere. Okay? Now, if I'm on the equator, I can see it. It's in sight. It's just on the horizon. If I'm at the North Pole, it's directly above me. If I'm here, let's say at, 45 degrees north latitude, which is around here on the Earth, okay, I can see it. Anywhere in the northern hemisphere, anywhere up here, I can see it. But if you go down to the southern hemisphere, I'd have to look through the Earth to be able to see it, so I can't. Okay, so you can only see it in the northern hemisphere. That's the first thing that's important. Now, the other thing that's important is the idea that the altitude of Polaris is your latitude. So, what does altitude mean? Well, imagine you're standing at night looking at Polaris because you found it with the Big Dipper, and you found it, and here it is in the night sky. You could measure the angle above the horizon. So here's your line of sight. It's parallel with the horizon. And you spot it, and you measure the angle of the star. The angle of the star is called the altitude. And that altitude, or that angle above the ground, is equal to the latitude where you are. So if this altitude, let's say in my picture, is, it looks something like 40 degrees, okay, well, that means I'm at a latitude of 40 degrees north. So that's super important. That's a concept that you're going to see a lot of and a lot of questions on in the future. Okay, so that's how we work out those 2 points that were presented here. Okay, so this is the same diagram I just drew. At the equator, if you were to look for it, it would be right on the horizon. Okay, it would be at an altitude of 0. Why? Well, the equator is at a latitude of 0, so you see it right on the horizon at an altitude or an angle of 0. At the 30 degrees north, you can see here the angle is 30 degrees, and that's because you're at 30 north. If you're at the North Pole, it would be directly above you, what's called the zenith. So it's directly above your head, 90 degrees, and that's because you're at 90 degrees north. Okay? Now, things that are important. Well, I already answered this question. Where would Polaris appear in the sky if you were standing on the North Pole? The answer is straight up, or 90 degrees, or at your zenith. Where would Polaris appear if you were at the equator? It would appear on the horizon, or at 0 degrees above the horizon. Okay, both of those answers are good. So let's look at some other sample questions. Here's one right here, region style question. Okay, I just answered this question. Where would you see Polaris, or where would you see Polaris on the horizon? The answer is the equator. So that one is number 1. This is a great question. Let me show you all the possible answers. As a ship crosses the prime meridian, the altitude of Polaris is 65 degrees. What is the ship's location? Well, remember, the prime meridian is 0 degrees longitude. Polaris tells you latitude. So you're looking for 0 longitude, which would be one of these first two choices. And remember, Polaris is also called the North Star. You can only see it in the north. So therefore, the answer is this second one. All right, let's take a look at one other one. This one is going to require your reference table. So if you look, it says that this observer sees the Polaris at an angle or an altitude of 42 degrees above the horizon. That's the important number, up from the horizon, up to her line of sight at Polaris. So you're looking for a latitude of 42 degrees north. Now what you might want to do is you look at your reference table, find your reference table, find which city or which location is closest to 42 degrees north. And if you do this correctly, you should get Kingston, New York as your answer. It's very close to 42. All right, here's another one that's very similar to it. We're looking for Polaris. Polaris is right there. It's on the horizon up 42 degrees. And so you're looking again for somewhere close to 42 degrees. And the answer to this one is Slide Mountain. Okay. Here's a few more. This one's a great one. If you are a passenger on a ship and you're observing Polaris, but you're sailing from New York to Miami, well, in New York, the latitude is somewhere around 41 degrees north. But if you go down to Miami, the latitude gets less. And therefore, the altitude of Polaris is going to get less. It's going to decrease. It's going to be coming closer to the horizon. So it says each night the altitude decreases in the northern sky. Remember, Polaris is in the northern sky always. So the answer is number 1. Okay, so that's a little bit about Polaris. Again, it tells you your latitude. These are the big takeaways from this. It tells you your latitude. You can only see it in the northern hemisphere, and you can find it with the Big Dipper.